Hello, dear friends. In this video, we are going to see about data wrangling and cleaning using pandas. So, if you think what actually data wrangling means, simply saying it is like cleaning our data frame. So, what are things we are going to discuss in this session is we are going to see what is data wrangling, how to handle the missing value, how to remove the duplicates, and how to rename and reorder the columns, fixing the data type, string cleaning, outlier detection. These are the things which we are going to see in this video. So first of all, to do this, we want two libraries from the Python. So first I'm going to use pandas. So import pandas as PD. Next one is, as we discussed, import numpy as NP. So numerical Python, and we want the data, no? So we want that we are going to use data in the form of data frames. Data frames means in the form of rows and columns. Why we want the data? Even we know that already we know the data structures of Python, like dictionary. In the dictionary also we can store lot of information, but we are going to convert those data in the form of a data frame. So what is the purpose means data frame is going to have the data in the form of rows and columns. And if you want to do any operations in the data frame, it is very easy to do any operations, deletions, removing, filtering, cleaning. All these things are very easy to do in when the data is in the form of data frame. So for that, we are going to use this library pandas. And if you want to know which version of panda library I'm going to use, you can know it by PD dot under double underscore version double underscore. So here 2.2.2 version is used. So this is the first thing we want to do. That is importing the necessary Python packages. Next is what is data wrangling. So it means it is also called as monkeying or cleaning. It is the process of transforming the raw data, the messy data into clean and useful format. Because we know that data is the fuel for all the process in the current trend. So if the data is not clean, if those unclean data or a messy data, we are going to give to a machine learning algorithm or a deep learning algorithm, or if you're going to do any analysis on algorithm, that's not going to give a better result. So before we are going to use this data, we want to make the data perfect and clean so that the data or the insight which we get out of this data will be more useful, and it will be accurate result also. So that's why we are going to do this process. So data wrangling means we are going to clean the messy data and make it into a useful format. That is what data wrangling means. So what are the things you have to understand here is common problem in the data frame is they may be missing data. For example, you consider in a data frame. Data frame means I said it will be in the form of rows and columns. You consider there is a column called age. In the age, instead of having age like 18, 20 or 25, if it is having NAN, not a number, so that is a missing data. So instead of having an age like 16, if it is having NAN, so we are missing some data. So we have to do a remedy for that. Similarly, duplicate, same value, if it is repeating for more than once, there is no use of it. So that can be taken care. And wrong data type. So age should be always in the form of numbers. So if it is in the form of string, we can do a necessary correction method for that. And inconsistent text means so for example, Python is case sensitive. So if you are taking the unique value from a particular column, consider there is a column called gender. This is all are in small case. Here the first letter alone is in the uppercase. The here all are full of uppercase. So when you ask the Python to choose the unique value, it will take all the three values as unique one. Even though they are same, conveying the same message, it will be considered as a three unique values. So we want to make this as a one data. So this is all called inconsistent text. And if there is an extra space here, you can see before and after the name Alice, there are some extra space. We have to remove it. And outliers means unusual data or unusual values are all outliers. For example, age means most probably it is from 0 to 100 or 99. So no one's age will be 999. So that is an outlier. Abnormal values are outliers. Or unusual data are outliers. So we want to find if there is an unusual data or abnormal values, we know that it is going to affect the insight which we get out of that. So if we take an average of an age, then this value will make other values wrong. So we want to take care of this as well. And then the wrong format. For example, usually we'll say day, month, a year. And if every dates are in different format, so it is very difficult for us to understand something. For example, date and months are mixed here and there, means that also will make problem in understanding the date. So wrong format should also be taken care, and it should be brought in a correct format throughout. They should have a uniform format. So all these things should be taken care when we do the data wrangling, that is the cleaning process. So let us see one by one. So here we are creating a missing data set for our purpose. So here we have a dictionary. So the dictionary have some keys. So dictionary is a key value pair. So here I have some keys like name, age, gender, salary, city, and joining date. And here in the name. So here we have with one of the sample name is none. So if a name is none, there is no use of that particular sample. And here you can see this age is none. So here is a missing data, and here is also missing data. And you can see each and every elements here in this are different what to say, uppercase, lowercase, title case, everything is mixed here. So that should also be taken care. And here a salary is missing. So here is also some cities missing, and the date is in different formats. So we have to bring it to maybe like day, then month, then the year. So this all should be taken care. So intentionally we are creating a messy data like this, and we are going to try to correct it. So let us see one by one. So first, initially data is in the form of dictionary. Now I want to convert this dictionary in the form of data frame. So as I told you in the beginning, we are going to use pandas for that, and we have given an alias for this pandas library, that is PD. So we are going to use that. PD means it represents pandas. So PD dot data frame. So the data, this dictionary is the data, right? So that needs to be converted in the form of data frame. And I'm going to store it in a variable df. So df is now in the dictionary is now converted into a data frame, which means it will be now converted in the form of rows and columns. So here you can see original messy data is printed here, and data frame is printed. You can see this is our data frame. Initially it is in the form of dictionary. Now this is in the form of rows and columns, right? So that's the speciality of data frame. So this data is now in the form of df, that is in the data frame. Now what is df? Df is a variable or object where we have all this dictionary data. So we want to know the shape of it. Shape means how many rows and columns are available. If you see, there are 10 rows are available. So the row is 10 and the column is 6. 1, 2, 3, 4, 5, 6. So totally 6 columns are there. So the 6 columns are displayed here. So that is what shape means. So shape give you the rows and columns of the data frame. Hope you have got it. Next one is, so let us go one by one. First, we are going to use we are going to get the basic information about our data frame. So data frame means we know that our data is fully, this is our data frame, this is our data frame. So for this data frame, we are going to get the information about this data frame. So we just have a simple print statement that is printed here. And then for this data frame, I'm going to get the information. So what are the information I'll get means, so it will give you the details such as how many not null values are there. So it is going to take each and every, so there are, you know that already six, we know in the shape there are 6 rows are, sorry, 6 columns are there. So it is going to display all the 6 columns, and it is saying, is it not null? So how many not null value, which means without null value. So 9 values are not null. So only we know that only one value is null value. None means null value. So it is showing 9. and then 9 not nulls are there. And how many not nulls count is there? So 9 not null. And what is the data type of name? Name is a categorical data, so it will be coming as object. It's a alphabet kind of data, right? So it is in the form of object. And then age, if you see here age, it is in the form of numbers and it is in the form of float. It is not 25, it is a 25.0. So it is in the form of float 64. Gender is also text like data. So it is an object. And salary is a float data. And this is object data. This is date. So if you see here, city is object, salary is float, gender is object, join is also considered as object because it's not a single number, no? So these are the information about this data frame. So if you print info, it will give the column name, each column's not null value and its count. So 9 not null values and its data type. So we are summarizing. So we have the data types like float and objects, and what is the memory usage? That is what info is. So now we are going to set the missing values. So totally how many? So here it is giving not null value, which are the not null values. So here we are going to find now. So if it is not null values are that much, now we are going to specifically get it. How many then null values are available? So this missing value is printed here in the print statement, then df data frame is null. So in every column, so if we just, that's a speciality, we don't want to use a for loop to iterate to each and every column and to find it. So here we don't want a for loop at all. If you just say the name of the data frame, automatically it will iterate for every columns and or every rows or whatever there, it will do it for whole data frame. That's the speciality of data frame. So here when I say df dot is null dot sum, so I'm going to find the null values and I want the sum of it, which means total. So in name column, only one not null value. In age, only one. Gender, 0. So there is, if you see in the data frame, gender, all the values are filled. There is no null value. So it is 0 is coming. Similarly, if you see in the salary column, only one we have NAN, which means not a number. And here in city, there is only one. And in the date, there is nothing. So here you can see date 0, city only one. So that's about is null. So df dot is null means how many is null, its count. And then next one is we want to find the missing percentage. So we want to find the percentage. We know how to find the percentage. So df dot is null done. Then we know how to find the total length into 100. So out of this 10 rows, how many are not null? How many are null? Okay, that is null. And then into 100 will give the percentage. And then I'm going to round it for one decimal place. So here you can see how many percentage. 10 percentage is missing in name, which means out of 10, one is missing, right? So that is 10 percentage. So in gender, 0 percentage missing value. So likewise, it is, so this is giving the percentage. So this is how we can check in our original data how many values are missing. Then next one is checking the duplicate. So in the beginning itself, I showed you how many, what are the things we are going to check. So missing value we found. Next is we want to find the duplicates. So these are the common problems in the data frame, right? So here we want to find the duplicates. So you can see here for that, I'm going to use a function called df, that is in the data frame. So duplicate rows I'm going to show. So I'm going to find df dot duplicated. So how many duplicated values are there? And I want the sum. So there is only one. What is that is this. You can see the index value number 1 and 5 are both same. So if you see here, number 1 index, this is the index column automatically added to have. Here the index are in the numbers. It is not compulsory that this index column needs to be number. You can give some text also like ONE1, TWO2, like that also you can give. So if you see here, this first index row and the fifth index row, you can see both are same. Every values are same. So it is a duplicated row. So that is what mentioned here. So we are using duplicated function to find the duplicate value, and I'm finding the row. So you can see this. So duplicated rows are this both. So first I'm finding the sum, so it is saying duplicated one, and then I want the duplicated rows. What are they? So I'm finding df from the data frame. I'm finding df dot duplicated keep equal to false, means I want the first occurrence of the duplicated row also. So that is why keep equal to false, which means I want the first occurrence also. So keep it. So that is what the meaning. So I got both. So keep false means mark all the duplicate row as true. So here all the duplicate row are shown. So that is what. So keep all the duplicated value as true. So that is what false means, including the first occurrence also displayed. So otherwise it will not show. So I have to say keep equal to false. So to make it display all the duplicated row, including the first occurrence of the duplicated row. So that next one is handling missing value. So now we saw from this we can understand the missing value we found, and also we found the duplicate value. So now we know that the missing values are there. So what we are going to do with the missing values, what we are going to do next. So first I'm going to take a copy of the original data frame. So the original data will not be get affected. So I just take df dot copy, and I'm keeping it in another variable, and we are going to work on is this. Hereafter the data frame will be we are going to use this variable, right? So now we are going to say this is the data frame name now, dot drop na, which means we are going to drop the values which is not a number or null values, and so that is the missing values, and we are going to drop it for the subset, which means the column. There are 6 columns in the subset column name. If there is a not, for example, the name itself is not there, then what is the meaning of having such row? No. So we are going to remove that particular row completely if the particular name is not there in the row column. That is the meaning of this. So from this data frame, I'm going to drop not available value in the subset column name. So after dropping the row, if we are going to see the shape. So previously, if you see, there are 10 rows and 6 columns are there. So when I drop one particular row, then there will be 9 rows. So you can see here, 9 rows and 6 columns after dropping the value. So what is the next thing is, so here is how we can drop a particular row completely if it is having a not a number, not available. And the next one is filling. Okay, here since the name itself is not available, we completely remove the row. Now if the age value is missing, then what we are going to do is we are going to take the median center value of the age and we are going to replace it. So first we are going to find the median age. So in the data frame df underscore clean, that is the data frame name. In that we are going to take the age column. In the age column we are going to take the median value and we are going to store it in a variable. Then we are saying that in the data frame, in the age column, wherever there is a null value, missing value, replace it with median age. So median age already we found it, right? So we are going to fill the missing value with this median age, which we found already. So in the data frame underscore clean data frame, in the age column, this will be applied. So we are going to take the median value. It is in the variable, and wherever there is a not a number, it is going to replace. Even you can also do one more thing. The same thing I can do in this format also. This is also same as this. Both will do the same thing. But here one thing you have to understand very clearly is, here we are going to do the assignment. So what it will do means it will do this correction and copy it back to this data, this column. So here what it is going to do, here we should, if we are using in place equal to true, in place means we are going to do the correction in the original data itself. Directly we are going to do the change in the original data. So that is what in place equal to true. So here it is not like that. It is taking a copy of this, do the correction, then copy and replace this value. Do the correction separately and copy that value to here. But here in place, if I put to same thing only in the age, so I have commented it because both are same only, no? The data frame on the age column, fill the null value with data frame dot medium. The age medium is taken. In place is true means do this in the original copy of the data frame. If I don't put in place as true, it will not put it in the original column. That's the meaning. So fill the missing value with age. What is the median age? We are going to print it here. So filling the median age is 29. Okay. And then filling, so we did it. Now filling the missing age with median. So we are filling it with median. Here we can fill it with mean value. So same thing, we are going to take the mean value, store it in this variable, and again same thing we are doing. Wherever in the data frame, in the salary column, wherever there is a null value, fill that with this mean value. That will be copied in this particular original data frame. And then we are also just printing only the mean value with a zero floating value. So here this is the spins I gave point dot dot 0f means I don't want any decimal value. So you can see it is not having any decimal value in the mean. Similarly, fill the missing city with unknown. So for example, here you can see in the city column, you can see there is a one value is not null, not available. So what I'm going to do here is, here you can see in the data frame, in the city column, if there is a null value, replace that null value with unknown. So it is going to, wherever there is not a number or not available, it will be replaced with unknown. So now we have taken care of all these things. So we just took age value and replaced salary column, we replaced with mean. And in the city, there also, so some here, where are the null values in the age column? This is taken care. In the name, if it is null, we completely removed it. Gender, there is no null value. Salary, this is replaced by the mean value. City, we replace this with unknown value. So all the null values are taken care. Now what we can do? We can now use null value column. So df underscore clean is null. Sum, we are going to get the sum of it. So now you can see there is all are zero, which means there is no null value now. Previously, if you see here, the null values here for name, there is one null value. For age, there is one null value. Since we taken care of all these null values now you can see all the null values become zero. So now as of now, there is no null value. So here I have given some explanation. Without in place means it will creates an updated value and store them back here. But if replace means it will directly do the change in the original column itself. So if fill NA means filling not a number value in the data set with a specific value. That is what fill NA means. So hope you got it. Now let us go to removing duplicate value. So already we saw. So before removing the duplicate column, we know the shape is we already, when I remove the name, 10 samples become 9, right? So because already we removed the name row, because the name row is none. So as of recently we did it, so we can know that 9 and 6, which mean 9 rows and 6 columns are there. So initially now df dot clean shape is 9 comma 6, that is 9 rows and 6 column. Now what we are going to do is we are going to see the duplicated value and we are going to remove it. So df dot clean, in that we are going to apply a function called dot duplicate. So already we know 2 rows are looking similar, so one will be deleted. So after you remove it, so previously it's 9 rows are there. After removing the duplicate column, we can see it is 8. So before and after, what is the shape of this data frame is displayed here. So duplicate values, I hope you can understand now. So we remove the duplicate also. This is that. Now let us go to the next thing, fixing the data types. What is fixing data type? Already I told you can make the data type as integer, because previously if you see the data type of age is here, you can see in the info. You can see in the data type of age is float. Usually we'll not say my age is 20.7. We will not say like that. We'll say either 20 or we'll say 21. So instead of making the age as float, we are going to convert it into integer. So how to do is, I'm going to say the data frame name, which column, age column, I'm going to convert its data type into integer. So as type is a function, help us to convert from float to integer. And now salary also we are going to convert to integer. So, and it will be, so this change will be done and copied back to this column. And similarly here in the data frame, I'm going to take the salary column and we are going to convert it into integer and copy the change back to this data frame. And similarly, date time. So we are going to fix it. So for that, we have a function in Pandas to date time. So in the data frame, we are going to take the join date column and we are going to give to this function, make it uniform and store it back in this column. So now you can see the changes, updated data types. So previously we know what was the data type, object and float were there. So now after we change the data type of age to float to integer, so now it is displayed as integer. Salary also we changed data type, so we can see the change has happened. And now you can see all this data. So this is what the data type displaying. So we are just displaying the data type of each and every column in the data frame df underscore clean. So that is the use of this line. And this line will print us the complete data frame. So here is our complete data frame with 8 rows now and with 6 columns. Now let us go to string cleaning, text inconsistency. So already told, so Python is case sensitive. So if we use different cases in for the same value, it will take it as a unique. So let us take that into also consideration. We are going to work with string. So what I am doing first is remove the extra white spaces. So in the data frame, I'm going to take the name column and the dot string dot strip means this is a string data type. In that I'm going to strip. Strip means it will remove the extra spaces before and after the name. So then, and I'm going to make it as a list and I'm going to show. So this is, you can see previously before and after Alice, there was some name. So now after removing the unnecessary spaces, you can see now there is no space. So that is the use of this print statement. So we are printing this column in the form of list. That is what this is, to list. So this column we are going to take and print it in the form of list. And then we are going to standardize the title case. So we already showed you previously in the beginning, gender column is having different one. One is fully small case. This is title case. This is uppercase. So this we want to address. So for that, what we are going to do here is we are going to take care of that what the cases. So for that, what I'm going to do here is I'm going to take the gender column and I'm going to find the unique value. So if I ask the unique value, see all this, actually there is only two unique value, female and male. But since the like font cases are different, it is taking everything as a the like five different values, but actually we know gender is only two. So what you are going to do is, first I am going to take the gender as a string strip, which means remove all the unnecessary spaces. Then in that string you are going to make it as a title case. So title case means first letter will be capital letter, rest of all small letters for every word. So you can see now after we do this title case conversion and copy back into gender, now I am going to find the same thing which we did here. So in the data frame, in the column gender, take the unique value. So now you can see after we do this change, now we have only two unique values. So that is what we can able to, this is how we can make able to standardize or make it uniform. So title means convert the text to title case. The next one is handling outliers. Already we learned what is outliers means, abnormal values. So age means 0 to 99 or 100. If I have 200 age, then it is not a normal value. It's an outlier or abnormal value. If you have such kind of outliers, it will skew our data or bring lot of wrong interpretation out of the data. So it is very necessary to correct it. So you can see I'm going to take the data frame in the age column. I'm going to describe it. So if I what is describe what is info will give data frame dot info means it will give information like the count of not null values and also it will give the data type. But if I use dot describe this function, it will give the minimum value, maximum value, mean value, average value, everything. So I'm asking for the column age. So you can see for the column age, the minimum value count totally 8 rows are there. So count is 8. Mean is 148, standard deviation, minimum value 25% of the data, 50% of the data, 75% of the data, maximum age mark. So there is an outlier here, right? So for the age column, we have just printed the age column. Now that is what describe will do. So describe will give you the count, mean, standard deviation, minimum value, maximum value, the quartile values, 25%, 50%, 75%, and what is the data type. It is all displayed here. So now what I'm going to do is I'm going to age 999 is, we know really it is wrong data. So I'm going to take data frame, I'm taking the age, and whatever is greater than 100, you are going to take it and I'm going to put it in this data frame. From the data frame, I'm going to take only this rows. So you can see here the which row is having the age greater than 100. That's what we are asking, row with. So in this data frame, I'm going to take the row, the sample which having the age greater than 100. So which row is having for the Frank? The age is 999. So it's an outlier. So what I'm going to do is I'm going to take that outlier, that is this condition, and then I'm going to replace it with the median value, the center value. So replace the outlier age with median value. So what I'm going to do, location means to find a particular value in a particular place. So location will use uh, label to locate the particular value. So we'll see in the next video about that location. So from the data frame, I'm going to locate the age with the condition age greater than 100. And then that should be replaced by, I'm going to take the age value, its median in the data frame, taking the age column, taking the median center value, convert it into integer and replace it in that particular position with the age greater than 100. So now after displaying it, you can see now again, once again, we are going to find the describe. So now you can see what is the mean value previously is 148. Now you can see the mean value is only 27. Mean is average. So when I have 999 in my data set, the mean value itself is 148 average. But when I corrected, that is after I remove this 999. So where we are removing, whenever the age is greater than 100, I'm replacing it with median value. Then I'm using this function describe. So what does it do? You can see now clearly it is corrected. Every value will be changed. So that is a speciality. Minimum value is 22, that's same. And earlier the maximum value is 999. So now the maximum value is 31. So it's clear. So we can understand data frame dot loc will locate particular rows and columns with the using of labels. So this is the syntax of .loc location. So we have to give the row condition followed by the name of the column. So that's what we used here. So we give the condition and the name of the column when I use LOC, which means where you locate something with the help of label. So that was the syntax. So whenever the age is greater than 100 for that particular age, that's the meaning. Next one is feature engineering, adding new columns. So that is also a process. So already we know that in our data set, what we have is we have a column called joining date. Instead of having a column as data joining date, if we have a particular column which specify the experience, then it will be more and good, right? So it will be easy for us to understand. So I'm going to do feature engineering. Feature engineering, we know from the existing column, we can create a new column. That is what so every column represents a new features. Represents a feature. So from the existing feature, if you're going to create a new one, or extract a new feature, then it is feature engineering, adding a new column. So we are going to add a new column to our data frame, that is df underscore clean, that is year of experience. So how will I'm going to do is, so I'm going to take the today's date, that is pandas timestamp today. It will give today's date. From the today's date, I'm going to subtract the date from the column. So from this data frame, I'm just going to take every column by column, and from that I'm going to take the days and divide it by 365 so that I'll get the clear number of days. So that is what this, and then I'm going to give the value for this new column, year of experience. So this will be done for each and every value in the column of join date. So now what I'm going to do is, now the year of experience is here. I'm going to add, so that is what feature engineering. From the available existing features, the columns, we can able to create a new column by extracting the value from the existing one. So for that, I'm going to use df underscore clean. I'm going to create another one new column named salary category. And what is PD? PD means pandas. I'm going to use a function called cut. What this cut will do means it will categorize my full data in that column into so many bins. Bins means like a bucket. And I'm going to say a range. For that, I'm going to give, instead of a numerical value, we can give some categorical value with the means. For this column, salary, I'm going to create three bins, which means from the value from 0 to 55,000, one bucket. From 55,001 to 70,000, one bucket. From 70,001 to this value, it is in the next bucket. So if it is the first range, it is labeled as low. Second range, this is 55,001 to 70,000 is medium, and the next one is high. So what is actually happening? It is going to take, cut is like used to divide the data into intervals. So it is going to take the column called salary, and this salary is divided into three buckets with this range. And for every range, I'm going to give a label for that. So salary category will be having three unique values: low, medium, and high. Now we are going to print our data set, our data frame. So first we have as usual name salary. So this is a new column added, that is salary category, with the values which we gave us low, medium, high. Low means it is 0 to 55,000. So you can see 0 to this salary is between 0 to 55,000. So it is considered low. Above 55,001 to 70,000, it is median. So it is now easily written. And year of experience. So from this date, it has added a new column called year of experience, and it has given the year of experience. So this is called feature engineering. From the existing feature, we are going to add a new column by extracting the data from the existing one. So that is what feature engineering is. So timestamp will give us today's date, and clean employee, this and all we know. So when I subtract the current date from, so here this is what the explanation for this. So here we are subtracting the today's date from the already available date. So that is what here. So when I subtract, it will give the difference between data. dt dot date means extract the number of days. When I subtract, it has so many days, like month is there, year is there, date is there. So I'm saying particularly when you subtract, you take only the days. So for 50 days or 100 days, and then divide that by 365. That is what the meaning. So when I convert into divide, it will give only the numerical value, integer divisions. So it will not give the decimal value. So convert the days into years. So I can know how many number of years of experience. That's what we want. The 10 years, right? Year of experience is what we want. So that we are doing division like this. This, if you put double slash, we might have, you might have learned in operators in Python, and it will give only the value before the what to say decimal value, which means after this remainder will not be taken. So that's what the meaning. So it will give the numerical value. So cut function will help the data to divide into three categories. So it will divide the full data into three categories, or you can change it also as you like. So now we can display the final one. So after we do all these operations, I'm going to display all this data. So what does reset index means? See, It has actually every data set has some numbers. See, this is what the index value. Usually it has, see what is reset index. Some index means for every pandas data frame, every row it will by default give the value as 0, 1, 2, 3. But after we removed it, filtered it, we removed the names row with the name null value. So there is one index is missing, no? And then we removed the duplicate value. There also one index will missing. So continuously you will not have the value as 0, 1, 2, 3 because in between some values, index value missing. So after that, I want it to bring it to the content. So after I remove the name and after I remove the duplicate value, the index will be like this: 0, 1, 2, 3 is not there, 4 is not there, 5 is there, 6 is not there, 7 is there. So because of now changes, it may be like this. So we want to bring it back to the continuous value. That is what reset. So it will start reassign the index value once again from the 0. So it is like instead of having 0, 1, 5, now it will change to 0, 1, 2. So what is drop equal to true means older index is added as a new column and you are going to add the new one as remove the older index and make it this index as a new one. So if you don't put drop equal to true, then it will not have the new value. It will be like this. So that is the meaning. So now you can see here, I'm resetting the index and now you can see the index is very continuous and then you can see the shape. It is 8 row and 8 column now. And then now if you see there is no missing values also because we have cleaned the missing data, messy data into a useful data. Now the data is perfect. If you give to any machine learning algorithm or if you apply any statistical formula, or if you want to do any kind of insight analysis, it will give a perfect one. So before we do any analysis or before we give your data set to any of the machine learning or deep learning or any AI algorithms, if you clear all this kind and then if you give, it will give a perfect data. So this is what called as data wrangling. Hope you have understand it. Thank you. God bless you.